According to National Electrical Code (NEC) Article 680.21a, an insulated equipment grounding conductor is required for all branch circuits supplying pool equipment. This requirement encompasses heating equipment used for permanently installed above-ground pools. Therefore, utilizing non-metallic sheath cable sleeve to polyvinyl chloride (PVC) pipe is not an approved wiring method for this particular application due to the absence of an insulated equipment grounding conductor within that wiring configuration. To comply with NEC regulations and ensure electrical safety, it's crucial to employ a wiring method that incorporates an insulated equipment grounding conductor. Acceptable alternatives include type metal-clad MC or armored cable (AC) cable, both of which inherently provide the necessary insulated grounding conductor. The purpose of this regulation, specifically NEC Article 680.21a, is to mitigate potential electrical hazards associated with swimming pools and related equipment. The presence of water and electrical components in close proximity necessitates stringent safety measures to protect individuals from electric shock. An insulated equipment grounding conductor offers a low impedance path for fault current to return to the source, thereby facilitating the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault. This rapid interruption of the circuit minimizes the duration of exposure to hazardous voltage levels, significantly reducing the risk of electrical shock. The specific requirement for an insulated equipment grounding conductor as opposed to a bare or uninsulated conductor stems from the corrosive environment often encountered around swimming pools. Pool water typically contains chemicals such as chlorine or bromine, which can degrade or corrode metallic components over time. If a bare equipment grounding conductor were to corrode, its effectiveness as a grounding path would be compromised, potentially leading to an increased risk of electrical shock. The insulation on the grounding conductor provides a protective barrier against corrosion, ensuring the long-term integrity and reliability of the grounding system. Furthermore, the insulation helps to prevent unintentional contact between the grounding conductor and other conductive surfaces, which could create unintended ground loops or introduce noise into the electrical system. When selecting a wiring method for a pool heater, it's essential to carefully consider the specific requirements outlined in NEC Article 680 and other applicable sections of the code. In addition to the requirement for an insulated equipment grounding conductor, the wiring method must also be suitable for the environmental conditions in which it will be installed. For example, if the wiring will be exposed to direct sunlight, it must be sunlight resistant. Similarly, if the wiring will be buried underground, it must be rated for direct burial applications. It is also crucial to ensure that all electrical connections are made properly and are protected from moisture and corrosion. The use of appropriate connectors and enclosures is essential for maintaining the integrity of the electrical system and preventing potential hazards. Before commencing any electrical work, it is always advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. They can provide expert guidance on the selection of appropriate wiring methods, grounding techniques, and other safety measures to ensure safe and reliable electrical installation. Let's delve further into the rationale behind the NEC emphasis on insulated grounding conductors around pools and spas. The primary concern is minimizing the risk of electric shock, and this is addressed through multiple layers of protection. Firstly, an insulated grounding conductor ensures a low impedance path back to the source in the event of a fault. This low impedance is critical because it allows a large fault current to flow quickly. This large current is what trips the circuit breaker or blows the fuse, rapidly disconnecting the power and preventing a sustained shock hazard. Secondly, the insulation itself plays a crucial role, especially in the corrosive environments common around pools. Pool chemicals like chlorine and bromine are highly corrosive to metals. A bare grounding conductor, even if initially providing a good connection, can corrode over time. This corrosion increases the impedance of the grounding path, making it less effective at carrying fault current. The insulation protects the conductor from this corrosion, maintaining its low impedance over the long term. Thirdly, the insulated grounding conductor helps to prevent unintentional grounding. In other words, it reduces the chance of the grounding conductor accidentally coming into contact with other metal objects and creating a path for stray current to flow. Stray currents can cause corrosion of metal equipment and, more importantly, can create a shock hazard if someone comes into contact with the affected equipment. Now, let's contrast the approved wiring methods, like metal-clad MC and armored cable AC, with the non-metallic sheathed cable and PVC conduit, which is not approved in this scenario. Metal-clad MC cable consists of insulated conductor surrounded by a metallic sheath. This metallic sheath serves as both a physical protection for the conductors and as an equipment grounding conductor when installed with appropriate connectors. The key advantage of MC cable is its durability and its inherent grounding path. Armored cable AC is similar to MC cable, but the metallic sheath is typically a spiral wound steel or aluminum strip. Like MC cable, AC cable provides both physical protection and a grounding path via its metallic sheath when correctly installed. In both cases, the metallic sheath provides a robust and reliable grounding path that is less susceptible to corrosion than a bare conductor. In contrast, non-metallic sheathed cable, commonly known as Romex, consists of insulated conductors bundled together within a non-metallic jacket. While non-metallic sheathed cable does include a bare grounding conductor, it is not considered to be an insulated equipment grounding conductor as required by NEC Article 680.21a for pool equipment. Furthermore, when non-metallic sheathed cable is installed in PVC conduit, the PVC conduit provides physical protection, but it does not contribute to the grounding path. The bare grounding conductor within the non-metallic sheathed cable remains the only grounding path, and it is not insulated. The NEC permits non-metallic sheathed cable in many applications, but it is specifically prohibited for branch circuit supplying pool equipment due to the enhanced safety requirements associated with swimming pool environments. Choosing the correct wiring method is not just about complying with the NEC, it's about ensuring the safety of people using the pool. A properly grounded electrical system minimizes the risk of electric shock by providing a safe path for fault current to flow. This allows overcurrent protection devices, such as circuit breakers, to quickly trip and disconnect the power in the event of a fault. Ignoring these requirements can have serious consequences, including severe injury or even death. Remember, electricity and water are a dangerous combination, and swimming pools create an environment where the risk of electrical shock is significantly increased. The NEC regulations are designed to mitigate this risk and protect people from harm. Therefore, it is crucial to adhere to these regulations and to use only approved wiring methods and grounding techniques when installing electrical equipment around swimming pools. If there is any doubt about the correct way to wire a pool heater or other pool equipment, it's always best to consult with a qualified electrician. They have the knowledge and experience to ensure that the installation is safe and compliant with all applicable codes and regulations. They can also inspect existing installations to identify any potential hazards and recommend corrective actions. In summary, when wiring a pool heater, always use a wiring method with an insulated equipment grounding conductor, such as Type MC or AC cable. Never use non-metallic sheathed cable sleeved in PVC conduit, as this does not meet the requirements of NEC Article 680.21a. Prioritize safety and consult with a qualified electrician if you have any questions or concerns. It's also good to review local electrical codes, as they may have additional requirements beyond the NEC. The NEC is a minimum standard, and local codes can be more stringent. When considering the broader scope of electrical safety around swimming pools, several other key aspects deserve attention. Firstly, equipotential bonding is a critical technique used to minimize voltage gradients in and around the pool area. This involves connecting all metallic parts of the pool structure, including the pool shell, metal fittings, pump housings, and any nearby metallic objects, to a common bonding grid. By bonding these components together, the potential difference between them is reduced, minimizing the risk of electric shock if a fault occurs. Secondly, ground fault circuit interrupters, GFCIs, are essential safety devices that detect small imbalances in current flow and quickly interrupt the circuit. GFCIs are required for all outlets and equipment located near the pool, providing an additional layer of protection against electric shock. Thirdly, regular inspections of the electrical system are crucial for identifying and addressing any potential hazards. This includes checking for damaged wiring, corroded connections, and malfunctioning equipment. Any repairs or replacement should be performed by a qualified electrician. In addition to these technical considerations, it's also important to educate pool users about electrical safety. This includes warning them not to use electrical appliances near the pool, to keep electrical cords away from the water, and to be aware of the signs of electrical hazards, such as tingling sensations or sparking equipment. Furthermore, it's important to maintain a safe distance between overhead power lines and the pool. The NEC specifies minimum clearance requirements for overhead power lines, and these requirements must be strictly adhered to. If there's any doubt about the clearance distance, contact the local utility company for assistance. Furthermore, consider the placement of electrical equipment. Any electrical equipment associated with the pool, such as pumps, filters, and heaters, should be located at least 5 feet from the inside wall of the pool, unless specifically listed for closer proximity. This helps to prevent accidental contact with electrical equipment while in or near the pool. It is crucial to remember that electrical codes and regulations are constantly evolving to reflect advancements in technology and to address emerging safety concerns. Therefore, it's important to stay up to date on the latest requirements and to consult with qualified professionals when making electrical installations or modifications. Ignoring these regulations can have serious consequences, including fines, legal liability, and, most importantly, an increased risk of electrical shock. In conclusion, ensuring electrical safety around swimming pools requires a multifaceted approach that includes proper wiring methods, grounding techniques, equipotential bonding, GFCI protection, regular inspections, and education. By adhering to these principles and consulting with qualified professionals, you can create a safe and enjoyable swimming pool environment for yourself, your family, and your friends. And always remember, when in doubt, consult with a qualified electrician. They have the expertise to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations.